So the time has come for us to finally get started on physics properly. We're going to do that by introducing right now really the centerpiece of the entire course, which is going to be studying Newton's laws of motion. So Newton's laws of motion is kind of arguably where physics really started at the beginning. It's kind of our original understanding of the fundamental question of this course, which is why do objects move the way that they do? Now, it's very easy to just state Newton's laws of motion and they sound very straightforward, but they're actually very hard to understand. Like, I could state Newton's laws of motion to you and they would make perfect sense, and then I could give you a quiz that like most people would probably get 0 on, because it's so hard to really wrap your head around what these laws actually mean. So let me try to be kind of careful about explaining this. So I think what I want to do first of all is kind of incorrectly explain why objects move the way that they do. This is, you know, I'm no historian, but this I think is more or less kind of how the Greeks understood motion, which they did a lot of really brilliant stuff, but they were not actually very good at understanding motion because of how counterintuitive motion actually is. Okay, so let's imagine that we're trying to start from square one and explain why objects move the way they do. Okay, so let's do some experiments on this block. I'm gonna be using my daughter's toys probably for a lot of experiments in this class. Okay, so we have this block here, right? Observation number 1. If I just leave the block sitting here, it does not just like spontaneously start moving. So, you know, an object at rest will just remain at rest if you don't do anything to it. That much is true. But now let's see what happens when we apply a force to this object. Okay, if I apply a force to the object, it moves. And then when I stop applying the force, it stops moving. I can move it some more. And then when I stop applying the force, it stops moving again. So it seems like very straightforward that when you apply a force to an object, it moves. And then when you stop applying the force to the object, it stops moving. And that seems very obvious, but it's actually completely wrong. And that's one of the most misleading things in physics, in this kind of introductory physics course, is that that's not how motion works at all. You actually do not need a force to have motion. You know, thinking that like you have to have forces to have motion is the biggest conceptual mistake that people make. Let me give you a very, very simple counterexample, okay? Forget the block. Let's do the same experiment again with this ball. All right, so once I get the ball stabilized on a level table, the same first statement is true, that the ball won't spontaneously start moving on its own as long as it's on a flat level table. And the second observation is still true, that when I exert a force on a ball, it's going to start moving. But the difference is when I release the ball, I can just give it, you know, a very gentle nudge. And that's all it takes for the ball to go all the way across the room and fall off the table. So clearly from this experiment here, the ball does not require a constant application of force in order to keep it moving. That's a really key point. The ball does not require the constant application of a force to keep on moving. In fact, if you just give the ball a little initial push to get it moving, it does require a force to get moving in the first place. But once you apply that first force to get the object moving, you do not need to keep on applying a force to keep it moving all the time. And the difference between these two things is the block is actually the more complicated of the two cases. With the block, there's very strong friction between the block and the table, which complicates the problem in a way that we are badly oversimplifying. So this is going to take some more explanation later on. But the ball actually has very low friction between the ball and the table. So the force I'm applying is really the only force that's affecting its motion in any significant way. So for that reason, the ball is actually the better example. And if you want to understand motion, you should picture it more like what would happen to a ball rolling across a surface, or what would happen to, another good example is like if you're on ice, like a hockey puck on ice. You know, if you're watching a hockey game, the guy does not need to constantly apply force to the puck in order to get it to the other end of the end of the ice. Like, you could be standing at your own goal and just give the puck a gentle nudge with the stick, and if no one else touches it, it will drift all the way to the other end of the ice, and you'll get icing against you, you know, because because there's no friction or very little friction on that ice. It's the similar situation to rolling a ball, where you don't need that constant application of force to keep the object moving. So that whole long-winded description is the essence of Newton's first law of motion. So let me try to write it down. I like to write these kind of in my own words, because I think the standard way that people state them, while concise and, you know, sounds good and is not wrong, it's kind of misleading if you don't really wrap your head around exactly what the laws are trying to say. So let me kind of say it my own way. Newton's first law of motion, there's going to be 3 laws of motion, by the way. So this is the first one. Newton's first law of motion says that the kind of natural state that an object goes to if there are no forces acting on it is not being at rest. It is traveling at constant velocity. So in other words, when I stop pushing on the ball, it doesn't stop. It keeps moving at exactly the same velocity it had when I stopped pushing. So in other words, forces are required to change the motion of objects, but they are not required to maintain motion that is already present. In fact, you actually need a force to get rid of motion once you have it. So you need a force to add motion to the system. You also need a force to take away motion from the system. And you also need a force to change the amount of motion that's in a system. I'm being very kind of nebulous about like what exactly does amount of motion mean. We'll get to that later on. But this is the essence of Newton's first law, that if there are no forces acting on an object, let me state that more simply. If there are no forces acting on an object, or if the total force on the object is 0, so there could be forces, but they all add up to 0. If there are no forces acting on an object, it will travel at constant velocity. And here's where the earlier sections of the course come into play. When I say velocity, I'm using that term very, very deliberately. I mean exactly velocity in the language of what we learned a little bit earlier in the course. So velocity here means velocity vector. It includes both the object's speed and the object's direction of motion. So as a result, in other words, what I'm saying here is that constant velocity means constant speed and constant direction of motion. So that means motion in a straight line. So yet another way of kind of saying Newton's first law of motion is basically that if there are no forces acting on an object, it will move at constant speed in a straight line. So you have to have a force to change the speed of an object. You also have to have a force to change the direction of an object's motion. So in order for an object to be moving in any kind of curved path, there has to be a force acting on it that's causing the path to curve. And we'll come back to all these things later and explain them in more detail. But that's the basic essence of Newton's first law. You know, this concept that objects tend to keep moving the way they are currently moving is called the object's inertia. That's called the object's inertia. So that's what we mean if we encounter the word inertia. And that actually is the same way we use the word inertia in everyday life. We say, like, you know, I have some inertia, like I can't get started. But inertia also means if you have some inertia, it's hard to stop you, because, you know, once you get going, you want to keep going. But if you're not moving yet, you don't want to start. That's like the essence of what inertia really means. And that's the essence of what Newton's first law is really all about.